So, so this is a 1-hour version, as Chris said, of the workshop that we've normally been doing a 3-hour version of. And I wanted to get started just by confirming to everybody that there's a lot more in the code than we can cover in this hour. So this is generally just an overview. At the end of the presentation, we'll leave you with some contact info so you can get more information. And in particular, I would say that anybody who wants to comply with the new version of the code should get the new handbook. And there's a lot more information in there than there is in this 1-hour presentation. As Chris said, we're going to kind of move through this. We'll have a little space for questions at the end. You can submit those questions by typing in that chat box, and we'll try to address those as best we can when we get to the end. So I want to start off by talking about the scope of this code and which buildings it applies to. It's a residential code, which means that it does not apply to commercial buildings. It also does not apply to commercial portions of mixed-use buildings. It's also what's called a low-rise code, which means it does not apply to buildings that are more than 3 stories tall. So basically, we're talking about residential construction of 3 stories or less. In mixed-use buildings, 3 stories or less, this code does apply to the residential portion of the building. It also applies to additions. Those of you who have dealt with the code in the past may remember that it used to apply only to additions of 500 square feet or more. It now applies to all additions, regardless of size. And one of the big changes for this year is that it now applies to renovation work. Basically, as any changes in the building should trigger at least the question of whether the work you're doing falls under the scope of the code. Gut renovations will require some kind of code-related action, typically. And basically what the code says, and again, there's much more detail in the handbook, but in terms of our overview here today, the way you can think about it is that once you open up building cavities, then you may or may not be required to do something with the code. The code does not require you to bring wall assemblies, for example, up to the full R value required by the code for new construction, but you are required to fill cavities with insulation if they're not already full. Also, there is a minimum efficiency for windows now in the code, and that applies to all window replacements regardless of scope. So even if your total scope of work is just replacing a couple windows, those windows do need to comply with the code. One other thing in terms of the addition and renovation work is that the code does not require you to change any portions of the building that are not already in your work scope. So anything that you're planning to change may be affected by the code, but you're not required to go further into the building than that. So if you're building an addition, it's only the addition. You don't have to change the main part of the house. If you're doing renovation, the work that you're doing may fall under the code, but you do not need to expand your scope of work to start working on other portions of the building. I wanted to touch just briefly on log homes because the Vermont code treats log homes differently than all other forms of construction. Most of our builders, of course, don't get involved in log construction, but for those of you that do, you might need to know that in your code compliance activities, you have to make sure that you're looking at the right stuff for log homes. Log homes fall under a special category. In general, they're allowed to be slightly less efficient than other construction. But because you're dealing with a wall system that has a lower R value than is currently required by the code, you may have to do other things in the building to partially make up for that. There are exemptions. There's an exemption for extremely low energy use buildings. Most of you do not need to worry about this. Extremely low energy use is defined as less than 1 watt per square foot peak load. The way that we describe this often is that for, let's say, a 3,000 square foot house, that means you have to be able to heat the house on the coldest morning of the year using no more than 3,000 watts. For those of you who don't really have a feel for what 3,000 watts is, It's basically 2 small hair dryers. So if you can heat your house with a couple of hair dryers, then you may be exempt from the code. The code does not apply to mobile homes. They're regulated at the federal level, and they're outside the scope of our state energy code. But it's important to understand that modular housing, manufactured housing, does have to comply. So mobile homes are exempt. Mobile homes are what most of us think of as trailers. They come with a permanent chassis, and they basically are rolled onto site, and the chassis stays in place. Modular or manufactured housing, as most of you know, is intended to be placed on a permanent foundation. Components are maybe built elsewhere. That assembly does need to comply. Manufactured homes are treated the same way in the code as site-constructed homes. Buildings not heated or cooled are exempt, or areas of buildings that are not heated or cooled are exempt. Formally designated historical buildings are exempt, and hunting camps are exempt. And I just want to point out that the hunting camp exemption is not part of the national code on which our code is based. It's a Vermont-specific exemption. And it's worth noting that this does make a difference because the code does not distinguish between seasonal use buildings and full-time use buildings. So if the building is heated or cooled, it needs to comply with the code. So this does apply to things that we might consider to be hunting camps. If it has, for example, a gas space heater in the living room, that's a building that's being heated or cooled. It's a residential building, and it does need to comply unless it's a hunting camp. There's also a special place carved out in the code for what's called owner-builder projects. The fundamental idea here is that someone who is building a house for themselves to live in can build it any way they want. They're not outside the scope of the code entirely. There are reporting requirements, but they are exempted from meeting the technical requirements of the code, which means the R value requirements, window efficiency requirements, that sort of stuff. Basically, they can do what they want there. There is a formal definition for the owner-builder. The owner-builder must be the person who is directing the details of the construction. So this needs to be a person who is involved on a daily basis in the project, presumably on site a good deal, and making a lot of the small decisions about how the project is going to be run. They have to be actually running the project. They also have to end up living in the building. And if they meet those requirements, they can, if they choose, call themselves an owner-builder. They can build a house any way they want. They still have to do the calculations. They still have to figure out whether or not the house meets the code and what would need to be done to it to meet the code. And they still have to file paperwork. Unlike a regular home builder who files the certificate at the time of completion, the owner-builder is not required to file a certificate until they're ready to sell the house, and they have to disclose in writing to any potential buyers before they enter into a purchase and sale agreement that the house does not meet the code and why it does not meet the code. When the legislature created the code, they did not create a system of inspections. They did not create a system of fines and penalties. The teeth in the law, the liability, is the liability of the builder to be sued by the homeowner. The legislation says that the homeowner has a right to sue. If the house does not meet the code, the homeowner can sue for any increased energy costs as a result of non-code compliance. And they can also sue for whatever it would take to bring the building into compliance, which presumably might be a significantly larger number. There is a six-year limit on those claims. So after 6 years, the homeowner can no longer sue the builder. One way that I encourage folks to think about how this process works is that there are essentially 3 separate things that the builder needs to do, and we'll talk about each one of them. The first one is what we call the basic requirements. There are a list of 12 or 15 things that more or less all houses in Vermont need to do. So we'll run through those very briefly in this presentation. There's much more detail, as I said, in the handbook. But we'll let you know what those basic requirements are. So every builder needs to do those. Secondly, there is an overall performance requirement. The idea with the code is that the main requirement of the code is this overall performance. The builder is allowed considerable flexibility as to how they put the pieces of the building together, but in the end, the builder is responsible that the building does not use more energy than is allotted for it. Basically, once you decide to build a house of a certain size in a certain location, you have an energy budget, and it's the builder's job to keep the consumption below that. There are 3 methods that a builder can use to determine whether they meet the overall performance requirement, and we'll step through each one of those as well. 2 of them are do-it-yourself methods, and the third one is having somebody else verify compliance. The first method, the simplest one, we call the fast-track method. This is essentially packages. So the builder can pick a package that has certain insulation and efficiency requirements. They include in their building everything that's in the package, and they meet the performance requirement that way. That method probably works best for simple buildings using fairly conventional construction styles. It's not adaptable to a lot of variety. The second method, which is also a do-it-yourself method, is a software method. Fairly easy. We'll give you a quick look at the software. Basically what the builder does here is they describe the entire thermal envelope of the building. So the entire layer that separates inside from outside will be described in the software. For each piece of the building, you'll be entering an area in square foot and an efficiency measurement of some sort, which is the R values for walls and ceilings and other opaque assemblies, and U values for windows and doors. Those are the 2 do-it-yourself methods. There's also a home energy rating method. Many of you probably already know that home energy ratings are a third-party certification of the energy efficiency of a building. And that's another way that a builder can demonstrate compliance. In Vermont, most or all of the home energy ratings done in the state are done under the Energy Star Homes program. So this is basically, not entirely, but for the most part, this is a pathway for people who are building an Energy Star home. And the home energy rating is already included in that process, so that kind of comes with the package. So again, what a builder needs to do is to choose one of these 3 methods for demonstrating that they meet the overall performance requirement. The third thing a builder has to do is a certification. Our code is a self-certification code, which means that, again, you're not going to have any inspectors coming out to your building to inspect for residential energy code compliance. It's the builder's responsibility to determine whether the house meets the code and to sign a certificate that says that it does. So we'll cover the certification at the end. This is a single-page form that the builder fills out with details about the house and a signature on the bottom line that indicates that they have met the code. We're going to cover basic requirements first. As I said, this is a list of things that needs to be in place in all buildings, and regardless of whatever performance requirement method you choose, everybody's on the same page for this. So we're going to step through all of these things and give you just, again, this is in a 1-hour presentation. We can't cover every detail, but I'm going to give you the gist of all these basic requirements. First one has to do with air leakage. The code has always said that we're supposed to make a reasonable effort to make the building airtight. But with this new version in 2011, that has been tightened up a good deal. There's now more detail provided and more requirements. Basically, the intent of the code is that you try to make the building as airtight as you can, both between conditioned space and outside, and also between conditioned space and unconditioned spaces like an attached garage, for example. The builder is required to choose one of two methods for verifying that this has happened. One is a blower door test, one is a checklist. So you can have the house tested for air leakage using a blower door, and if it measures out at less than 5 air changes per hour at 50 pascals, have complied with the air leakage basic requirement. You can also do a visual inspection, and again in the handbook there is a listing of all of the items that are on the visual checklist. It's a rather detailed and moderately lengthy checklist, and the intent here is that, again, someone's going to actually visually and physically inspect the building and verify that all of these things have been done. There's a little detail on access hatches that's new this year. Access hatches must be weather stripped and insulated to a level equivalent to the insulation on the surrounding surfaces. I emphasize that a little bit because that's a rather stringent criteria. So this means, for instance, that your attic hatches are going to have to be insulated to the same level as you're insulating the attic floor. There's a couple other details there. Access has to be provided to any mechanical equipment that's up in the attic, and of course in Vermont we want to minimize whatever mechanical equipment is in attics anyway, but if you put anything up there that requires maintenance, you need to create a pathway so that some service person can come and go without trashing your insulation job. Also, there needs to be a sturdy baffle around the hatch to maintain the physical integrity of the insulation detail there. There's a requirement for vapor retarders. This has been not loosened up, I would say, but made more flexible with this version of the code. It used to say that you needed a Class 1 vapor barrier everywhere. Now it requires a Class 1 or 2 vapor barrier on above grade walls, and it allows you a Class 3 vapor barrier, a somewhat less vigorous vapor barrier, if you have one of those 3 wall details that's given on the slide there. The intent is that these are wall details that tend to be somewhat more forgiving in terms of moisture issues and therefore require a less vigorous vapor retarder on the inside. There are some new requirements for ducts, and some of these are rather stringent too. Now we're talking only about heating and cooling ducts, not about ventilation ducts. If you run any heating and cooling ductwork outside the thermal envelope, it now has to be insulated to the same R value as required for immediately adjacent surfaces. So this is much like the attic access hatch. And again, if you want to think about how you might end up insulating ductwork in an attic to the same level as you're insulating the attic floor. It's a rather rigorous requirement, and probably will serve as a deterrent to putting ducts in attics, which may be a good thing. All ductwork has to be air sealed. You can't use building cavities as supply ducts. You can use them as return ducts, but only interior cavities, not any cavities in the thermal envelope. There's also a requirement for testing the ductwork for air tightness if any of the ductwork or if the air handler itself is outside the conditioned space. So again, once you decide to run ductwork outside the thermal envelope, these new requirements kick in, and in addition to heavy insulation on that ductwork, the ductwork system, it needs to be tested for air tightness. Some of you on the call probably have never seen a duct tightness test, but the equipment that's used for that is much like a blower door, and the testing process is much like a blower door test. And you can see the requirements there. The amount of leakage you're allowed is tied to the size of the building, and it's also tied to when you do the test. The intent there is that at rough-in, the assumption there is that the air handler, or what we Vermonters think of usually as the furnace, is not in place and you're only measuring the ductwork. That's why you're allowed less leakage. If you are testing post-construction, the assumption is that the air handler is in place. We know that all the air handlers leak and that you can't do a lot about the leakage that the box has, so you're allowed more leakage if you're testing with the air handler in place. A couple of requirements on heating controls. Basically, you now need a programmable thermostat for furnaces, heat pumps, and boilers that have convective baseboards. It's not required for boilers serving radiant floors or for zones that are radiant. It's not required for space heaters or for solid fuel. There's also a combustion air requirement for gas and oil. All chimney vented gas and oil appliances must have dedicated combustion air. What this means is that there needs to be some sort of hole or ductwork from the outside to either the burner or the room that the boiler or furnace is in. That combustion air has to be provided as specified in the National Gas and Oil Codes, NFPA 54 and 31, and there are a couple of additional restrictions. Those two national codes, the gas and oil codes, allow the combustion air requirements to be met by the volume of the space. That is, if the volume of the space is big enough compared to the size of the burner, then the National Gas and Oil Codes say that you can meet the combustion air requirements that way. But our state energy code says you cannot do that, and the reason you can't do that is that all new homes are what is called unusually tight construction. You'll notice that phrase is in quotation marks. The reason for that is that that's a formally defined term in the gas and oil codes. And bottom line, if you do the kind of air sealing that our energy code requires, the building that you're building ends up being unusually tight as defined in the National Gas and Oil Codes, and therefore you cannot use the volume approach. You have to actually introduce air one way or the other. And there's one other limitation, and that is that the National Gas and Oil Codes allow taking combustion and dilution air from attics or crawl spaces, but our energy code specifically prohibits that, so that air has to come directly from outdoors. There's also a requirement for chimney venting. All chimney vented oil and gas equipment must establish spill-free draft within 2 minutes under worst case conditions. Worst case is when the building is completely buttoned up, as airtight as it can be, and basically all the exhaust equipment in the building is operating. So this test is done by closing all the windows and doors. Typically there are some interior doors that are closed as well to restrict the air supply even more. And every exhaust fan in the building is turned on: bathroom exhaust, kitchen exhaust, clothes dryer, central vac vented to outdoors, anything else that takes inside air and shoves it outdoors. Also, if there's a forced air system, that's included in the test. That fan is also fired up to see if that makes things better or makes things worse. And the intent here is that you're configuring the building to make it as difficult as possible for the chimney to work, and then we're verifying that the chimney works under those conditions. For solid fuels, basically that means wood to most of us. There has to be a gasketed door with a compression closure or a compression latch system. This applies both to wood stoves and also fireplaces, both manufactured fireplaces and site-built fireplaces. Also, combustion air has to be delivered directly to the firebox, except, as the code says, older stoves where that's not possible. You can either do that with a manufacturer-approved kit, or in the case of a site-built fireplace, you might be doing a site-built exterior air supply. And if you're doing that, you need to look at the code for the specific requirements for site-built combustion air to solid fuel devices. There's a requirement for mechanical ventilation in our code. You're required to have whole house ventilation, which means some sort of system of fan or fans that moves some minimum amount of air either into or out of the building on an automatic control. You also need local exhaust, which means capacity in the other bathrooms. There needs to be some scheme for automatic operation, either continuous or on some sort of timer, so that the ventilation system can operate without people having to remember to turn things on or off on a regular basis. There are minimum flow rates. You're required to move a certain amount of air based on the size of the building, and builders have two options for that. You can install a fan with a certain minimum rated capacity, and that number is going to depend on the size of the house. Or you can put in whatever system you want and have it actually measured to see how much air it's moving. There are also some miscellaneous installation requirements for ventilation systems. Most of these have to do with either constructing the ductwork so that the airflow is not restricted. Also, a couple of the installation requirements have to do with noise, trying to get the system reasonably quiet so it doesn't annoy people, they don't shut it off. This year, new in the code, there is now minimum efficiency for windows. The average U value of the windows installed in your project, so in a new house, this would be all the windows in the house, or in a renovation or addition project, this would be the windows that you are replacing. The U value cannot exceed 0.32. Skylights may not exceed 0.55. There's a requirement for insulation on hot water pipings, mechanical system piping, that is space heating piping, not domestic hot water, must be insulated to a minimum R3 if that piping is in unconditioned spaces. Let me just say now that the way the code defines conditioned and unconditioned spaces is such that the typical Vermont basement is considered by the code to be a conditioned space. So if you build your basements the way most of us build basements these days, with no insulation in the basement ceiling, with insulation on the basement walls, and with your air sealing detailing concentrating on those basement walls as opposed to the basement ceiling, that basement is considered to be conditioned space, which means that you do not need to insulate the boiler piping down there, if that's the way you're building the house. Also new this year is a requirement for lighting efficiency. At least 50% of the lighting fixtures in your scope of work must be high efficiency lamps, which basically means something better than a standard incandescent, so a compact fluorescent or equivalent. You are allowed to meet this requirement with screw-in compact fluorescents. They do not need to be hardwired. There's also a requirement for system sizing that's been changed this year. The code has always required that somebody do a load calculation to determine how big the furnace or boiler needs to be. It used to be the code stopped there. Now they say that in most cases you have to actually install equipment that is within a certain range of that calculated number. That sizing calculation has to be done using some approved methodology, the most common of which being Manual J. And if you're installing air conditioners or heat pumps, they must not be oversized by more than 15%. Fossil fuel appliances may not be oversized by more than 40%. There is an exemption there if the house you're building is efficient enough that you can't find a boiler or furnace small enough. And we know that that is the case sometimes, especially with oil-fired boilers. And in that case, you're allowed to use the smallest available unit. That is the end of the basic requirements. And now we're into the compliance methods. And again, just to orient, everything we've covered so far are the basic requirements. Everybody needs to do those. Now we're into the overall performance requirement. There are 3 methods for doing that, and we're going to step through what those 3 methods are. The first one is the fast track method, and as I said before, this is essentially picking a package. This is the simplest method. It's the one where the builder needs to deal with the fewest amount of numbers. But the counter to that is that it's also the least flexible method. It's limited in the types of homes that it applies to. There are only so many packages. And so you may find that none of the packages applies to what you are intending to do. The glazing percentage, which is the total glazing separating conditioned space from outdoors, divided by the above grade wall area, that percentage cannot be more than 20% for the packages. The code does not restrict the area of windows, but there are no packages for glazing percentages larger than 20%. And again, I'll just mention that the handbook has details on how you go about calculating that glazing percentage. Most houses in Vermont fall less, have less than 20% glazing. You can't use it for metal framing and exterior walls and some other building details that tend to be uncommon in Vermont. And if you're using the packages, you have to comply with the conditions that come with the packages, and I'll explain what some of those are just very briefly. The process on this is that you calculate your glazing percentage first to make sure that you're under 20% so that you can use the packages. You find the fast track table that suits your building type. Those of you who have dealt with the code in the past may remember that there used to be 3 building types: single family, multifamily, and log homes. With this round, that gets simpler because the requirements for multifamily are now the same as the requirements for single family. So there are now only 2 categories of buildings: log homes and everything else. So you find the table that's right for your building type. You take a look at those packages. You make up your mind whether there's a package there you can live with. If so, you build a house that way. You include the conditions that come with the packages, and you file your certificate when you're done. This is kind of just a brief outline of the conditions that come with the tables. This is most of it, just the major stuff. For the tables, your basement wall insulation must go full height from the top of the wall to the floor. Now, you're allowed under the code to build differently than that, but there are no packages that cover that. So if you want to do something other than full height basement wall insulation, you'll probably need to go to the software or some other method. Similarly, there are details on crawl space insulation. It has to go from the top of the crawl space wall to at least a foot below grade. There's also some detailing on slab edge insulation if you have a slab that is exposed at grade. The code does not require slab insulation for slabs that are well below grade, but it does require insulation on the edge of the slab if the slab is at grade, above grade, or less than a foot below grade. There's also a couple of options on floor insulation. If you have floors that are over unconditioned spaces, like a tuck-under garage, the packages will give you an R value that floor needs to be. If you build a floor section that is completely over outside air, then you have to insulate that floor. If you're using the packages, you have to insulate that floor to the level that's given for the attics. There's also a detail around attic eaves. As many of you are aware, that edge of the building where the roof slope comes down close to the top of the exterior wall is a problem to get full R value there because you typically don't have the height. Builders need to pay attention to that, and they either need to get full R value all the way out over that exterior wall, or they have to insulate the rest of the attic more heavily to make up for the fact that they don't have full R value all the way out over the walls. Also, you'll see it on the last line there, a small amount of window area and one door are exempt from the thermal requirements. That allows you to use some small decorative window or something that does not meet the U value requirement as long as it's no more than 1% of the total window area. And similarly, you're allowed to put in one door that is basically anything you want as long as the rest of the doors in the building meet the requirement for doors. This is what the packages look like. There are 4 packages for the non-log homes. You'll see in package 1, you'll see the ceiling R value there. The above grade wall R value you see as R20 or R13 plus 5. The 13 plus 5 refers to R13 cavity insulation and R5 continuous insulation. Obviously 13 and 5 don't add up to 20, but as most of you know, continuous insulation works better than cavity insulation. So for the purposes of these packages, R13 cavity plus R5 continuous is deemed to be equivalent to R20 cavity insulation. Under the basement crawl space wall R value, you'll see a similar kind of confusing number there, R15/20. What that means is R15 continuous insulation or R20 cavity insulation. Similarly, there's slab edge R values. There are additional slab insulation requirements for heated slabs, radiant slabs. The window and door U values are given there, and the skylight U value, and that's all package 1. Package 2 is similar to package 1, but you're allowed a somewhat less vigorous R value in the attic in exchange for better wall insulation. So if that works better for you, you could pick package 2. Package 3 allows you more flexibility on attic insulation than package 1 does, and it basically makes up for that difference with basement insulation. The requirement there is R20 continuous, and also you'll notice that that package requires slightly more efficient windows. So if that system works better for you, you might prefer that package. Package 4 is mostly intended for wall systems that have continuous insulation. So for the most part, this will be stress skin panels or insulated concrete forms. That's it for the fast track method. And as I said, for all of these things, there's a great deal more detail in the handbook. And we'll move now to the software method. This is a lot more flexible than the packages, and I think for many builders this will probably be the method of choice unless you're in the Energy Star Homes program. It's very easy once you've described the building to try variations, to change things, to play what if, and tinker around with things until you get some combination that you like and that also meets the code. No real big drawbacks to using the software other than the fact that there's a little more math involved, a little more data entry than with the packages, because the builder needs to describe the entire thermal envelope of the building, not just figuring out the glazing percentage. There are some conventions for measuring building components that I want to mention just briefly if you're going to use the software. The software is intended that the wall area is measured in the same way that most builders and carpenters think of it. And we mention this because probably everybody on the phone is capable of using a tape measure, but there's sometimes some confusion about where you put the end of the tape measure. So in other words, you don't measure from outside corner of siding to outside corner of siding. Neither do you measure from drywall to drywall. The code considers the wall dimension to be from the outside of the exterior framing to the outside of the exterior framing. This is the same as most carpenters think about it. In other words, a wall that's 24 feet long is 24 feet from the outside of framing to outside of framing. For windows, doors, and skylights, you use the rough opening size, not the size of the glass, not the size of the unit, the size of the rough opening. For basement walls, you basically look at each basement wall separately. For conditioned basements, which most of our basements are, as defined in the code, walls that are more than half above grade are considered above grade walls. They're kind of lumped in with the other above grade walls, have the same requirements as the other above grade walls. If the basement wall, that is the wall of the conditioned basement, is mostly below grade, it's considered a below grade wall, or what's also called a basement wall. This is how the code defines basements in terms of conditioned or unconditioned. A conditioned basement is obviously a heated basement, but the other way a basement could be considered conditioned is if it's an unheated basement below an uninsulated floor, which is the way we build most houses in Vermont. In that case, the thermal envelope is the foundation wall. You'll end up insulating the foundation walls, but you do not need to insulate the basement ceiling. And any ducts or pipes that are in that basement do not need insulation on them because they are considered to be within the conditioned space. If you choose to build an unconditioned basement, you can. In that case, you would have to insulate the basement ceiling, the first floor deck, and also any other building components that separate the basement from the house, like the walls and ceilings surrounded a walk-up stairway, if there's a stairway that walks up to the main house. In that case, you would not need to insulate the foundation walls, but you do need to insulate and air seal any ducts or pipes that are down in that space. Also, it might be worth noting that if your thermal envelope is the basement ceiling, then you have to do your air sealing at that level. And air sealing a first floor deck is more work than most people would assume at first, and probably more work than air sealing the perimeter of the basement. This is what the software looks like. For each section of the building envelope, you'll create a line. You'll note that there are some buttons up at the top with blue text labeled ceiling, skylight, wall, etc. If you hit one of those buttons, that creates a line, and that allows you to describe that component. So there, under the header called Assembly, you'll see that there are some drop-down menus there. That's where you choose the description of the section that you're dealing with. You'll enter then the area in square feet, and you'll enter in the insulation value as R values for the opaque surfaces and as U values for the windows and doors. You'll notice that the software distinguishes between cavity insulation and continuous insulation. It knows that continuous insulation works better, and so you just enter in what you have under the appropriate heading. If it's cavity, you put it there. If it's continuous, you put it there. You can create pretty much as many lines as you want here. So if you had, for instance, two different types of walls or two different types of attic floors, you can enter those quite easily. You just create a separate line for each and describe them exactly as they are. Down at the bottom is where you get your answer. You'll see a couple of entries there in green. On the left, you'll see a checkbox that's green and the word passes. And over on the right, you'll see that this particular building is 6.2% better than code. Immediately below there, you'll see a max UA and your UA. UA is simply the average U value times the area of the entire thermal envelope. You can think of that as the heat loss. So you have a heat loss budget, essentially. And in the case of this building, the budget is 288. So you have to stay below that. On this particular screen where it says UA and you see the number 270, that's the number that's calculated from the entry that you've done up above. So as long as your calculated UA is less than what you're allowed, then you pass. And as you can see in that 6.2%, the software doesn't just tell you whether you pass, but it tells you how much you pass by, whether you're just barely passing or whether you're passing comfortably. And of course, if you don't pass on first attempt, then you just ask yourself, well, what can I do to this building that's reasonable and that will improve the thermal performance? And you make those changes in the software, and the software will tell you immediately whether you pass or not. So that's it for the software thing. I'll just describe briefly the home energy rating. As I said, a home energy rating is a third-party certification, so somebody else does most of the work. It takes more things into consideration than the other method. It's a somewhat more sophisticated method. In some cases, not all, but in some cases, this may make it easier to pass simply because you get credit for things that the other methods do not accommodate. For example, the first two methods make assumptions about how airtight the building is, whereas the home energy rating uses an actual measurement of air tightness. So if you're tighter than the assumption, you get credit for that. Similarly, the home energy rating can take passive solar into account. The other two methods are not able to do that. You basically supply the building design, and somebody else goes through the process of figuring out whether that complies. As I said earlier, for the most part, ratings in Vermont are done under the Energy Star Homes program. That's already a standard part of that process. So those of you who are building Energy Star homes, you can use that home energy rating that you get along the way to demonstrate code compliance. Basically, you give staff details on what you have in mind. There's a review of that game plan, some recommendations typically made, then you decide on what you're going to do. There are 2 physical inspections of the building during the process. One is pre-drywall, where there is an inspection that is mostly focused on air sealing and on the quality of the insulation installation. And then there's another inspection upon completion. And when you get all your paperwork from the Energy Star Homes program, you'll also get the Energy Code certificate all filled out. The builder still needs to sign the certificate. The builder still assumes the liability for code compliance, but the certificate is filled out for you. This is what the certificate looks like, and regardless of your method of compliance, everybody needs to fill out the certificate. It includes a few details about the house, R values, size, location, that sort of thing, and a section on the bottom where the builder basically signs assuring and promising that the house has been built to code. You fill that out at completion. You post 1 copy in the house. You file 1 in the town land records, and you send 1 copy to the Public Service Department. You can get these certificates from the Energy Code Assistance Center. If you ask for a handbook, you'll get your first certificate along with that. It has to be signed, has to be posted. The originals of the certificates are adhesive back, so you just stick them up somewhere near the heating or cooling equipment or the electrical service panel. And you are required by law to send 1 copy to the Department of Public Service, and also to have 1 copy formally recorded in the town land records. And the town copy is a formal recording, and that'll probably cost you, I hear, $8 or $10 in most towns. The copy that gets sent to the department is not a formal filing. It's simply a Xerox copy that you mail to them. And you're supposed to do all of that within 30 days of completion. So to review, what do you need to do? Basically, you need to do 3 things. One is you need to include all of the basic requirements in your building. Secondly, you need to pick one of these 3 methods to determine whether or not you meet the overall performance requirement. You either pick a package, you use the software, or you get a home energy rating. And regardless of which performance requirement you use, you are required at the end to fill out that certificate and, as I said, file 1 copy in the town land records, post 1 copy at the house, and send 1 copy to the Public Service Department. There are some folks who can help you out. We have what's called the Energy Code Assistance Center. There's the phone number you can see there. And you can go to Efficiency Vermont. I've already mentioned the Energy Star Homes program. Those of you who are building Energy Star Homes will get assistance with code compliance part of that process. Efficiency Vermont also has another service called Energy Code Plus. This is for builders who would like to do a little better than code, would like some help on code compliance, but are not building an Energy Star home. So that's another thing you could check into, is the service that Efficiency Vermont calls Energy Code Plus. And I'd also like to mention very briefly Efficiency Vermont's program called Home Performance with Energy Star. This is a program for existing homes, so it's a little different than Energy Code. However, especially now that the code applies to renovations, you might want to consider using one of the home performance contractors for part of your scope of work. These folks are all listed on the Efficiency Vermont website. They're essentially insulation and air sealing contractors, so you might want to consider them for insulating or air sealing if you sub that stuff out. The other thing is that all these folks have blower doors. They could do a blower door test for you if you want to use that compliance method. Also, they've all been trained to do this worst case depressurization test, so they could do that for you too. There's a couple of websites listed there. One is the site at Efficiency Vermont that is the Energy Code Assistance Center. You can get other materials there. You can get copies of handbooks and that sort of thing. You can, of course, call the Energy Code Assistance Center for verbal consultation. And there's some other resources there too. You'll find a link to the original code document. You'll find links to presentations, this presentation, also the full, you'll find the PowerPoint for the full 3-hour code workshop that we've been doing. And we also provide for you at the bottom there the Public Service Department's website and the page that they have where they talk about the residential building energy standards. So with that, this presentation is